Alright, this is just some chapter test review for chapter 1. We're putting some ideas in practice that we've learned about in this section. So in 17 they tell us that the measure, when they put M angle ABD, that means how big is the angle ABD in degrees. And they tell us that is 45. So let me outline that angle. I'm going to outline it just so we can see it a little easier. It's this green angle here that I'm drawing. Okay, that's ABD. That's 45 degrees. And then it tells us the measure of angle ABC is 120. So if I outline that one, ABC is this bigger angle here. You can see it if you can use some colors. And if you're a person that is very visual, it might help you to have some different colors. So the whole angle is 120, and so I'm going to write that here for the red. The little green angle is 45, and what they want us to do is find DBC. So let's outline that in blue. DBC is this blue angle. So this is where the angle addition postulate comes in. These two angles together, the small ones add up to the big one. So it would be, I could say, well, if I want to find this one, I could do algebra on it. I could call the blue angle X, and I could say 45 degrees plus X is 120 degrees. And I could solve it, or you could just look at it and say, oh, if 120 is the whole thing and 45 is the what we know, then if I just subtract those two, I'll get the DBC that they ask about. And so when we subtract that, we see that that ends up being 75. So that's how you do 17. Okay, on number 18, we see if EB bisects AED. So let's outline AED so that we can see exactly where it is. It's this red angle here. And it's telling us that EB bisects it. So even though it's not drawn, especially the way I drew it, and even on the picture, I'm not sure if it looks exactly halfway, we don't ever go by what a diagram looks like. We go by what we're told is true. So if EB is bisecting this, here's EB, that means that this piece is equal to all these pieces added together. And they tell us that DEB, this big angle here, and I'll outline it in blue just so we can keep it separate from the little green angle, DEB is 61. Well, now, because EB bisects the big angle, and this half is 61, that means the other half, the little green mark there for angle AEB, or we could call it BEA, that's also going to be 61. Okay, so we got this part 61, and now we know this part's also 61. Let's see what they ask us. As they say find the measure of angle AED. That's the red angle. You have to find the piece there first that's missing, or if you know that if you're looking for the big red angle, if you know that half of it's 61, you could double 61 to get the whole thing. If you've done what we did up here and labeled everything, it's just 61 plus 61, or you could just say double 61 if this 61 here, if we know that it's that much is 61 and that EB bisects it, that means the other half is also 61, and you could add that together, you get 122. Okay, on number 19, we get this diagram, and I had trouble with this one at first because I was like, how are they getting their answer? Because I've got the advantage of seeing the answer key, and I guess you do too because it is loaded for you. How many pairs of perpendicular segments are shown in the feature? The clue there is they're being tricky. They say segments, okay? So let's color code. One that's easy to see, and I'll do it in yellow, is first off that's two pairs right there, CS. And here's where this is where the tricky comes in. There's actually two, CS is perpendicular to SF, but there's another one here, CS is perpendicular to SE, because those two segments are not the same. So that's where they're going to count that as two. One going to this first point and one CS going to the line segment that has an endpoint of E. So SF and SE are two different line segments, so they're counting that as two, and that's tricky. That's what I was missing when I first worked this. If you were having trouble coming up with the same number they are, that may be your problem too. Now, Let's look at BD. They marked it. The reason I know they're perpendicular is this little box here means perpendicular, and so I know that BS is perpendicular to SD. And actually, that's how I knew that CS was perpendicular to SF and CS was perpendicular to SC. That there was also that little yellow box there. Now, I'm going to redraw this figure just a little bit just so you can see the other one. You probably see it, but I just want to make sure it's clear. If you just look at CS coming down, it makes a right angle here. And here's S, and then we have A over here. We talked about this area over here having, perpendicular line segments, but if this is perpendicular here, that means it's 90 degrees. And since these two angles make a straight line here, let me do that in a different color just so it's really, if that's a right angle there, I can be sure that this one over here is also a right angle, and if you want me to prove it to you, a straight line, or a straight angle, is 180 degrees. And if I take away the 90 degrees on the other side, I'm left with 90 for this angle over here. So the other one is, CS is perpendicular to SA. So that's where they're getting their answer. There are 4 line segments, so watch out for that just because they did it on this test. All the tests that I have are just different versions of each other. I would look out thinking that might happen on that other one too. Okay, look at 20 now. It says, which angle is supplementary to FSC? And they're referring to the same figure on your paper. And they want to know what's supplementary to FSC. Now first we have to remember that supplementary means 2 angles add to 180 degrees. If you're having trouble keeping complementary and supplementary apart, here's what I saw something, just sometimes making a picture with the word. Supplementary is 180, and what I've seen people do is go, oh, it's easy to make that into an 8, so it's 180. I don't know, they may be grasping at straws there. But complementary means it adds up to 90, and they would say, oh, it's easy to make that into a 90 just by putting a line on the C and making it a 9, and then you have that O. So complementary means 90 degrees, supplementary means 180 degrees. Just try to find some way to keep those terms straight. They're asking us about FSC. So it's this, I'll try to outline it heavy. What is supplementary to that one? Well, it's actually related to the problem they asked before us, if you think about it. Let me pick a green here. If what adds up to 180 degrees, if it adds up to 180 degrees, it's supplementary. Sometimes if they're right side by side, like this one is, we even call them linear pairs. So this one would be a linear pair here because it's also 90 degrees. This one was 90 and that one's 90. So the answer to that one would be angle ASC, or you could call it angle CSA. If you're using the multiple choice there, it's ASC is how they write it. Okay, I'm never going to make y'all any promises that problems are going to be exactly alike from test review to test, just because you've got to be able to think, and that's the deal, is trying to really get you ready for your SATs and problem solving and geometry. Okay, it says suppose AXB, BXA, and they don't tell us about how to draw this, and I kind of went ahead and drew what I was going to do with it, and CXA are congruent angles in the same plane with no common interior points. Now I've got a circle over there because in the end that's what we got to think about, but here's what I started. That's not how I started when I was trying to figure this out. I got stumped on this for a little bit. Let's say we got an angle. Here's what I tried to do. Okay, AXB. Let's say I make this A, and this is my vertex X, and this is B, because one thing I do notice about this problem is they all have the same vertex, and that's where it gets kind of tricky. Because if I draw AXB, I'm sorry, this should be, I miscopied that, that's BXC. BXC, if it's got the vertex at X, and all these have the middle letter of X, I know they've all got a vertex of X. So if I drew BXC like that, so far so good, but how am I going to get CXA? CXA, if, here's the A, and here's the C, and here's the X. These are all supposed to be congruent to one another, and I can tell they won't be because you can add this angle and this angle together to get CXA, so this is not working for me. Well, you have to kind of think outside of the box, and that's why this is the bonus problem. What if it were a circle? What if you had a circle, and they're all congruent, it says, and here's the key, and part of my problem is I like to read one line at a time, but there is an advantage sometimes to reading the whole problem first. It says the sum of their measures is 360. Well, that means we're talking about a circle. If we got 360 degrees, anytime we see that, we know we're kind of talking about a circle there. So these are all equal, and you add them all up, you get 360 degrees. It's like taking a circle and splitting it up into 3 equal parts. So even my drawing here is not going to work well, and I'm just going to draw another circle because that to erase that would take longer than just to redraw it. So if you know, you could kind of do a peace sign if you're ever trying to divide a circle in about 3 parts. Maybe we make it A here, X here, and B here. There would be AXB, our first angle. BXC, if I call this C, that would be my second angle, and they're all equal, so I'm just going to put one arc on each one of them to show that. And then CXA, oh, that's how I could get them to look, right? So it says that XY is the bisector of AXB. So let me draw XY in. It bisects AXB. Here's AXB. If I bisect it, let's say I draw it like this, and I'm going to kind of do this. I'm going to extend it because I've already read the problem and I know I'm going to need to draw it all the way through. Let's say now this piece is equal to this piece, okay? If the sum of their measures is 360 and XY is the bisector of AXB, which of the following is true? Well, AXY is not equal to BXC. I can tell that. BXC should be double AXY. Because since it's bisected, we just took that 1/3 part and we split it in half, and we still know the others are third of the angles, right? Okay, and so, you know, I can actually write these angles in there. If they're all congruent, wouldn't this one be, let me label in red, this one would be 120, this one would be 120, and then this AXB was 120, but when we split it in half, we got 2 little 60-degree angles here. Which of the following is true? Is AXY? AXY is 60 degrees on A. Is that equal to BXC? Is it equal to 120 degrees? No. You know, you can rule out A. Let's look at B. Is BXC, which is 120 degrees, is BXC equal to BXY? No, BXY is 60 degrees. That one's not true. C, XC and XY are opposite rays. XC is, let me do that in purple. It's right here. And XY, I'm sorry, XY is here. Now, I free drew this, right? I didn't get a compass out and measure a protractor and measure exactly. It looks like that could be true, but I'm not sure. So you know what? I'm kind of thinking C is a possibility, but maybe I'm not sure yet. How could I know? Well, let's look at it this way. You could know for sure. Let me get a color that I haven't used yet. I'll use kind of a salmon color. If I've drawn this right, 60 and 120 would make 180, right? That's half a circle, and that actually went to this XC right here. I wasn't sure whether my XY, when I extended it to this other side, you know, I wasn't sure whether it laid right on top of XC or not, so I didn't draw it that way because I just wasn't sure. But if I take this whole 120 degrees and that 60 degrees, it's 180. Well, look over here on this other side. I got 120 here, right? And then I got 60 more, so if I add that, it's 180. One of the definitions of a straight, you know, angle is that it's 180 degrees, and a straight angle is the same thing as a line. So what I can see is really that this XY is an opposite ray from XC. I should have, because I just eyeballed my drawing, it doesn't look like it exactly, but I could tell it was close. If I want to know for sure, I could look at these angle measures. We can look at, we better stop there.